Hi, welcome to this video. So what we're going to do in this video is actually give a quick introduction to glucose strip slash biosensor manufacturing. So what I mean by glucose strip manufacturing is obviously, a glucose strip is a iconic way of measuring glucose, for example, in diabetics. One of the first things you'll notice about a glucose strip is they're often printed, they're often made on a polymer background, and they have this kind of unique way of being able to automatically fill. So we kind of call it capillary fill. So there's a nice way of fabricating them. They function very well. They work on sort of opaque samples like blood. But let me jump into a little bit more on the actual manufacturing of these. If we're to analyze a glucose strip, the first thing that you'll do is you start to peel back the layers, is realize that there's several layers associated with this. And I'll break down each of these layers and their manufacturing in a bit. But the first thing we have here is kind of essentially a base layer. Now, on top of that, sometimes we have a spacing layer. Now, just to say that within this spacing layer, within this kind of rectangular cutout here, there's often an enzyme layer printed. So these are the enzymes that make that sensor, for example, specific to glucose in this particular case. So that's called the enzyme print. Now, over the top of this, there's often a transparent cover called the top layer. And this is where you'll often see the blood sort of wicking in. The blood wicks in, dissolves the enzyme, and starts doing the reaction. So the glucose slash biosensor strip has these kind of four main elements, but I break this down a little bit more as well. If we did a cross section across this, then what you'll see, for example, on the cross section here is that we have the sheet. This is often PET, polyethylene tetraphthalate. On top of that, there'll be some conductive inks printed. These are the kind of electrodes. Over the top of those, even though they're fairly transparent in this particular image, there's a insulator. Sometimes people refer to this also as a dielectric as well. Now, if we do a cross section across here, this is the kind of working end of the sensor. Then we have the sheet. We have, again, electrodes. We have the enzyme layer either deposited or printed on top of the often working electrodes. And then we have these cut-out double-sided adhesives, which are really forming the walls of a microfluidic channel. And over the top of that then goes a transparent layer, which I've labeled up here the top layer. Now there's an air gap between the, let's say, electrodes and the top layer. And that's the air gap really forms a chamber, which is really the heart of this kind of capillary fill action that hopefully you saw at the beginning of this particular video. Now this is the overall sort of workflow for glucose strip manufacturing. And I'm going to break this down piece by piece now. But what I want to say is that we also apply this to biosensor manufacturing as well. So glucose sensors have kind of laid out the blueprint, let's say, for manufacturing a glucose sensor, or manufacturing a biosensor, I should say. So let's break this down a little bit and say that when we look at a glucose sensor slash biosensor, we kind of have an enzyme solution. There's a whole process about making the enzyme solution, and this is not covered in this particular video. But we have a space layer, and this space layer is really that layer that kind of forms the walls of a microfluidic channel. We have the top layer, which forms the cover of that microfluidic channel. And I want to break this down a little bit more. So with that base layer, it starts off really with a roll of PET. Describe it here as opaque. It often may be black, maybe white, mostly white. This actually gets formed into sheets. Sometimes if somebody's doing really high volume glucose strip manufacturing, they actually do reel to reel, so it remains in sheets. But for other biosensors and for lower volume glucose strip manufacturing, it will remain in sheet, gets cut into sheets. Onto those sheets, then we're printing electrodes using conductive materials. Primarily in glucose, this would be carbon. Then we actually have this insulator, which is the next layer. Now what happens then is the enzyme solution gets printed onto what's called the carbon working electrode, and that's the kind of enzyme print or enzyme dispensing. The next thing that happens then is there's this kind of microfluidic capillary channel. So that's made by really taking double-sided adhesive material and cutting it, and then actually that gets laminated on top of the substrate where the enzyme has been printed, and so we kind of have this kind of lamination step. Now there's another let's say workflow running in parallel with the base solution, the space layer, and that's this top layer. So top layer may also be PET. It tends to be transparent, which is quite useful because then you can actually see, the user can see that their blood is like flowing into that sensor, and it gives a kind of visual cue that everything is running correctly. So that will get cut, dust is eliminated. You may not print your logo on top of it. You may not put stickers on top of it, but just to kind of include that sometimes happens. But what really happens is that transparent layer goes on top of the laminated material earlier on, and we now kind of close off the top of that capillary channel, and we call this kind of top layer lamination. Now the sheet gets cut. The sheet gets really cut into strips, and then the strips get singulated into individual sensors, and then we kind of have packing and then eventually shipping. One thing I should just mention actually is in this base layer where we first do the electrode printing, at ZP at least we do a lot of electrochemical testing on those electrodes just to make sure that the material that's coming into this workflow is reproducible, and I think that's something we do quite uniquely. So if you have any questions regarding this, here's the contact details of ZP, and please don't hesitate to reach out to us. Okay, thanks very much.